Let's solve the left rotation problem on HackerRank. In this problem, in the description, a left rotation operation on a circular array shifts each of the array's elements 1 unit to the left. The elements that fall off the left end reappear at the right end. Given an integer d, rotate the array that many steps to the left and return the result. For example, when d is equal to 2 in an array with values 1, 2, 3, 4, 5, after 2 rotations, this is what our output would look like, because if we move 1 to the left twice, it would appear where the 4 is, so 1, 2. If we move 2 times to the left, this is the first move, and then the second move would be where the 5 is, so there we go, 2, 1. 3 would be where the 1 is, 4 would be where the 2 is, and 5 would be where the 3 is. So the way we're going to solve this is mathematically. Let's go ahead and take a look at some examples to know what exactly we need to code. Let's look at this example. We have an array which is equal to 1, 2, 3, 4, 5. And we need to rotate the elements to the left either 0 times or array.size time. So in other words, 5 times. Well, obviously, if we need to rotate it to the left 0 times, that means we're doing nothing. We just keep the array the same. And if we need to rotate it array.size times, so 5 times, then the 1, if we move to the left 5 times, would go like this. So 1 would be here, then 2, then 3, then 4, then 5. It would just return to its place again. Similarly, 2, if we move it to the left 5 times, so this is the first time, second time, third time, fourth time, fifth time, the array is going to stay the same. So whenever d is equal to 0 or it's equal to array.size, we need to return the original array. Let's take a look at what happens to our array when we need to rotate it to the left 1 time. So if we need to move 1 to the left 1 time, it would be the last element in our list. Let's take a look at our updated array once we rotate the elements to the left once. So if we move 1 to the left once, it would be the last element in our list where the 5 is. If we had to move 5 to the left once, it would be where 4 is. 4 would be where 3 is. 3 would be where 2 is. And 2 would be where 1 is. So it would look something like this. So what do we notice here? Well, the element at position 0 is now the element at position 4, which is the last element in our list, because our indexes start at 0, so 0, 1, 2, 3, 4. And if we follow this trend, our element at position 1 would be at position 0. Our element in position 2 is now at position 1. And if we keep going, it would look like this. So once again, our element at position 0 is now our element at position 4. The 1 is now the last element in our list. The element at position 1, which was the 2, is now at position 0. Our element, which was at 3, is now at position 1. 4 is at position 2. 5 is at position 3. And like I said, element at position 0 is position 4. So actually, we can deduce an equation to see where our updated values would be. So P prime, which is the position or the new position of where the element we're on should be, is actually going to be equal to the array.size minus the number of rotations that we should do plus its original position. So for example, if we take the first element, so in our original array it's 1, then its new position P prime is going to be equal to array.size, which is 5, minus the number of rotations, which is 1, plus its current position, which is 0, and we get 4, which is coincidentally where it should be now. If we follow through with our second element 2, so P prime is equal to 5 minus 1 plus 1, which is equal to 5. So this may appear wrong because we don't have a position 5, right? It's 0, 1, 2, 3, 4, 5, and then 5 would just be out of bounds. But since they mentioned that it's a circular array, that means once we exceed array.size, so once we reach 5, we need to warp back to the beginning of our array. So elements at position 5 would actually be equal to position 0, elements at position 6 would actually be 1, at position 7 they would be 2, and so on and so forth. So actually, this equation still holds, but we need to warp, so we just need to identify that 5 is the same as position 0. And if we continue, so our second element, or third element, which is 3, would be 5 minus 1 plus 2, which is equal to 4 plus 2, which is 6, which is the same as 1, and so on and so forth. Now there's one more thing I want to mention before we begin coding. That's if the number of rotations exceeds the size of the array. In that case, like I said earlier when we were calculating our new position with the equation that we found, if the new position exceeds our array.size, then we'd have to warp back to the beginning at position 0. And similarly, if the number of rotation exceeds the size of our array, then we need to warp back. So what I'm trying to say is that d is equal to 6 is the same as rotating once, because let's take a look at one for example. If we needed to rotate it to the left by 6 times, it would be the same as rotating it to the left just once. So if we move it to the left 6 times, 1 would be where the 5 is, then it'd be at 4, then it'd be at 3, then at 2, then at 1, and then finally it will return to the position at 5. In other words, if the number of rotations exceeds our array.size, then the actual number of rotations that we need to do is d modulo n. For example, if we had to rotate 6 times and our array size is 5, that would be the same as 6 modulo 5, which is 6 divided by 5, or the remainder of that operation, which is 1. So rotating our array by 6 is the same as rotating it to the left once. So now with all these concepts established regarding the new positions and if the number of rotations exceeds the array size or if it's equal to it, we need to actually discuss what we're going to do. So we have these new positions and we know the value that we need to place in those positions. So what we're going to do is we're going to create a new list instead of the one that they gave us, and we're going to input at the new positions the values that should be at those new positions. So let's begin coding now. The first thing we're going to do is we're going to create a list of integer. We can call it list or output, or let's call it output, is equal to new array list. Now here's the thing. We cannot actually create a list of integer output equals new array list. In other words, we cannot create a empty list, because what we need to do is we need to set at certain positions, like I said, the values that need to be there. And if our array list is originally empty, then we cannot update, or we cannot put indices or positions and give them values, because we're going to get out of bounds. For example, if I needed to place in position 3 a value of, 4, it's going to give us out of bounds error because our array is empty and the index 3 doesn't exist. So we can bypass this in two ways. We can either put our old list, so what do they call it, array here, and now we're going to have a new list integer called output, which is identical to the array list they gave us in the given. Or what we're going to do is we're going to create a new list which is equal to the same size of the array that they gave us, but we have to fill it with values. We can't just create a list with a certain size and have no values in it. So we're just going to give it values of 0. And the way we're going to do that is like this. Collections.n copies we want n, which is the size of our array list, which I'm going to create now, and 0. We want to fill a list of size n with values of 0. So let's create n very quickly. Int n is equal to array.size. And while we're at it, let's create int p equals to 0. This is going to be our pointer to our original list, so we can iterate through the elements in our original list. Now, before we iterate through the elements in the array, what I'm going to do is I'm going to update our value d, which is the number of rotations we need to commit, to d modulo n. So in the case that d is greater than n, we're going to retrieve the actual number of rotations we need to do. And in the case where d is less than n, then d is going to remain the same. If we want to take a look at a quick example, if d is equal to 6 and n is equal to 5, then really we need to rotate to the left once, which is the same as 6 modulo 5. Since 6 divided by 5, its remainder is 1. And if d is equal to 4, and again n is equal to 5, then 4 modulo 5 is just equal to 4. We're going to do this so we can skip some if statements. Instead of saying if d is greater than n, then do this, otherwise do that. We're just going to have one block of code. So anyways, let's actually begin looping through our array list. And the way we're going to do that is we're going to create a while loop. And we're going to say while p is less than n. And obviously we're going to increment p until it's one value less than n, because indices start at 0. So now we're going to store in an integer called result the result or the new position where our value should be, and we're going to get that from the result of the equation which we established, which is equal to n, or array.size, minus d plus the position which we're currently on. So if that's the case, what we're going to do is we're going to output dot set, and what set does, as you can see here, we put an index and integer element. So we put at what position we want which value. So input dot set at what position, result modulo n, at that position we want to put array dot get the value at position p. Otherwise, if result is less than or equal to n, or less than, strictly less than, then output dot set result array dot get p. Before we terminate before we finish our while loop, we need to increment p, and then finally we need to return output. So let's submit our code and see if it worked. So actually I got an error when I first submitted the problem. That's because I had an extra bracket which I deleted. Otherwise, once I submitted again, it ran through all the cases and it was successful. So I hope you found that video helpful. That was the left rotation problem on HackerRank, and thanks for watching.